Today we'll be working on the following problem. Let E and F be two disjoint subsets of Rn, the n-dimensional Euclidean space, and E is Lebesgue measurable. And suppose that A is a subset of E, B is a subset of F, and M star is the Lebesgue automeasure on Rn. We want to show that the automeasure of the union of A and B is equal to the sum of the automeasure of A and B. So pause the video if you want to work on this problem by yourself. Okay, let's give a proof of it. So we know in general, the automeasure have this sub-additivity, right? So the automeasure of the union of A and B is less than or equal to the automeasure of A and B. Now in this setting, what does it tell us? That you have a E and F, they are disjoint, and A and B are subset of these two sets, right? And E is Lebesgue measurable. So if this A and B are separated by a two subset, one of which is Lebesgue measurable, then we have the equal sign. So we have this additivity. So let's, since E is measurable, right? So now we apply the Carathéodory criteria to test the set A union B. So by the Carathéodory criteria, since E is measurable, so we have this, the outer measure of A union B is equal to the outer measure of A union B intersects E, and then plus the outer measure of A union B intersects the complement of E, right? Since E is Lebesgue measurable. Now, if we work on this, this is A intersects E, union B intersects E, and then plus this A intersect E complement, and the union B intersects E complement, right? And now from this graph, we know this A is a subset of E, so this is A. And the B is a subset of F, which disjoint, right? So E and F are disjoint. So this one, B intersects E, is empty. And now, since A is a subset of E, so this one is empty. Now B is a subset of F, which is a subset of the complement of E, right? Because E and F are disjoint. So this becomes a B. So this is exactly the outer measure of A plus the outer measure of B. So we're done.